Welcome to lecture 47, design patterns. So, in the last lecture I talked about singleton, right, the singleton implementation we had seen in C++, Java, right. So, in this lecture I start with the alternative singleton implementation in C++, right. So, let us consider class singleton, right, as usual like previous programs. So, class singleton. So, here we have the private constructor singleton, right, and then you have another private instance, right. So, you call this as a eager initialization, right. So, this is called as a eager initialization. So, that means the instance will definitely occur, right. So, when I am creating an instance under singleton, right. So, this is called as the eager initialization, and then our usual get instance, right, which is the reference function under singleton class, and it will return instance, all right. And then you have one member function called show message. The show message, here you have cout singleton instance created eagerly, right. The class is over here. So, now we are initializing the static member, all right. So, instance is a static member, all right, under the class singleton, right. So, now we will go to the main program. So, the main program, so we have the reference singleton, right, because when we are calling this function get instance, right, when we are calling this member function, right hand side if you look, we are calling the member function, right, which is get instance. So, get instance if you see, so here you go, so this will return instance, right. So, like previously what we do, if it is pointing to the null pointer, right. So, we are creating instance. So, here since we have the eager initialization, that is called the alternative singleton, all right. So, the instance will definitely be there, correct. So, here you have the instance from line number 9 and 10. So, that will be returned, correct. So, and here you have the object, the reference object singleton, you have the instance. So, now this singleton, the object singleton, which is invoking show message, all right. So, which is invoking show message. So, when it is invoking show message, the singleton instance created eagerly will be printed, all right. So, the main idea of this program is the eager initialization, the instance will occur, right. So, therefore, we are writing, if you look at line number 9 and 10, when I have this get instance member function, right, in fact, it is a reference member function with the class singleton, so which is returning instance, right. So, when this singleton invokes show message, correct. So, we are getting the output singleton instance created eagerly, right. So, will be the output, right. So, will be printed. So, when I run the code, so I will get the output singleton instance created eagerly will be printed. So, this is the alternative singleton implementation. In fact, so when we look at line number 6, right. So, when you are creating the instance under singleton, so automatically the instance will be created, and we no need to write the null pointer statement that we had written in the previous singleton implementation. So, here automatically instance will be created, therefore, it will be returned. So, the explanation point of view, right, this is for your reference. So, here the instance is created at the time of class loading. So, that is what the eager initialization, the line number 6, right, the eager initialization, right. So, when you are creating a instance over here, so during this time, right, when you are creating at the time of class loading, all right. So, the eager initial, so instance will be created, right, the instance will be created at the time of class loading. So, you call it as eager initialization, that is line number 6. So, what are all the advantages of eager initialization in singleton pattern? It is a simple implementation compared to the previous one, we call it as a lazy initialization. So, whatever we had seen in the last lecture, you call it as a lazy initialization, because whenever you are creating an instance, so there is a possibility that it points to the null pointer, right. So, that is what we are modifying the code. So, you call that as a lazy initialization, and this one, the eager initialization, avoids issues related to uninitialized instances, right. So, the main drawbacks are, so this may lead to resource overhead if the instance is not used, all right. So, if you are not using instance, then there will be a problem. That means it may lead to resource overhead, and another important drawback is it is not suitable for resource heavy classes. So, this is all about your eager initialization in singleton pattern. So, now if you look at the next program, we call it as a singleton counter in C++, alright. So, let us have a class counter. So, the class counter as a private instance, it is a pointer object under counter, and you have one variable int count, alright, and you have a constructor counter, right, where count equal to 0, right. It is a default constructor where count is equal to 0, and in your public member function, it is a pointer member function, get instance, right. So, again we are going for the lazy one. If instance is equal to null pointer, right, if instance is equal to null pointer, you are creating an instance, creating a new instance, correct, where the constructor is counter. So, when it is calling the constructor means it is initializing to 0, alright. So, then whatever be the case, whether the instance already exists or you are creating based on this line number 12 statement, that means if instance is equal to null pointer, you are creating an instance, it will return instance. So, this we had seen several times, alright. So, now line number 18 void increment, alright, one of the member functions count plus plus and int get count, right. This is another member function which is returning count, right. So, your counter class is over here. So, now we are creating a object instance, right, pointer, right, pointer object initially pointing to the null pointer under counter, okay. So, now go to the main program. So, you have small c, counter is an object, the pointer object, alright, under counter. On the right hand side, it is invoking get instance, right. So, when it is invoking get instance, the instance will be created, right. So, this we had seen several times. So, here you have the instance will be created and it will be returning instance, right. So, now this counter is invoking increment, right. The counter is invoking the increment member function. So, when it is invoking increment member function, so here you go, right, count plus plus, right. So, when you are creating an object, right, under counter, right, in fact, the pointer object, so it is initialized to 0 because of the line number 8, right, it is initialized to 0. Now, the counter is invoking increment in line number 25. So, in that case count will be incremented by 1. So, now it is 1, count is 1, right. So, count is 1 and it is right over here, correct, in line number 8, alright. And similarly, counter is again calling, again invoking increment, right. So, when it is again invoking the increment, line number 18, again count plus plus, alright. So, count plus plus, it is the private member data of the class counter, right. So, 1 plus 1, now it will be 2, right, 1 plus 1, it will be 2, right. So, now see out count, so this will be printed. So, counter is invoking get count, right. When the counter is invoking get count, what will you get? So, it is returning count. What is count? Count is 2, right. So, count colon, so we will get the output 2, right. So, when we run the code, so we have to get this output, right. So, this is called as a singleton counter. That means I am creating an instance, correct, and if the instance does not exist, that means it is pointing to null pointer. So, we are creating a new instance, fine, right. Or if the instance already exists, whatever be the case, line number 15, we are returning instance under get instance member function, right. It is a pointer function, right. So, rest of them are clear. So, I am creating an object in line number 24, pointer object, and in the right hand side get instance, and we know that get instance will return instance, alright. So, therefore, when counter is invoking increment, so count is incremented by 1 and then again it is calling, count will be incremented by plus 1. So, 1 plus 1 it will become 2. So, when I run the code, we will get the output count colon 2, okay. So, this is what the output we are getting. So, this is called as the singleton counter in C++, right. So, what is the main purpose of explaining the previous code? So, when I am talking about the single counter, it maintains a global counter that can be incremented or retrieved. So, increment case we can see. So, simply if you put count, so it can be retrieved whatever be the count value. So, the count value will be printed. So, incremented or retrieved, alright. And the main features are the count variable is shared globally via the singleton instance. Yes, I did not talk about the global variable, right. You might be asking the question, so how when the second time when it is calling in line number 26, So, how it is being incremented 1 plus 1, right. So, here you go. So, when I am using the singleton counter, right. So, the count variable is shared globally via the singleton instance, right. So, this is one of the features. And another features, so the singleton counter ensures that only one counter exists throughout the application, right. So, only one counter, you will have only one counter, right. So, these are all the main features, and whenever you have functions like the member functions, like built-in member functions like increment, right, or get count, right. So, it is useful to increase the counter and to retrieve the current count, right, respectively, right. So, increment function which is for increasing the counter, and get count to retrieve the current count. So, this is all about the singleton counter example. So, now what are all the benefits and drawbacks of singleton pattern? So, we have talked about singleton pattern so far, right. So, the main advantage is it is ensuring a single instance of a class globally, right. So, either if it is pointing to the null pointer, or in that case we are creating an instance, otherwise the instance will occur, right, and it reduces the memory overhead by reusing the same instance, right. So, we are having only one instance, so that will be reused, and the singleton pattern which is providing a control access point to shared resources, right. So, these are all the main benefits of the singleton pattern. So, the main drawbacks are it is difficult to do unit tests due to global access, and the second case, I mean, this singleton pattern can lead to tightly coupled code and the thread safety issues. In fact, the thread everything we are going to study in the next chapter. So, the thread safety issues if not implemented carefully. So, these are all the main drawbacks of the singleton pattern. So, now the next topic is what is meant by factory pattern, alright. So, when we are talking about the objects, alright. So, how do you define this factory pattern? So, this factory pattern is providing an interface, alright. So, this interface is useful for creating objects without specifying their exact class, right. So, that is called as the factory pattern, and in fact, when I am talking about the factory pattern, so the decision of which class to instantiate, right, is delegated to a factory method. So, this is a added advantage what we had seen so far, right. I mean, in fact, this is another important feature, right. So, better than singleton pattern. So, here the decision of which class to instantiate, right. So, I assume that you have several classes, and then I mean we have to see factory pattern will have the decision of which class to instantiate to delegated to a factory method. And key features are abstracts object creation, right. The factory pattern abstracts object creation, and this is promoting the loose coupling, and it simplifies the code maintenance. So, loose coupling is nothing but between the systems, right, in the programming. So, now what are all the use cases for factory pattern, right. So, here you go object creation with variations. So, creating objects of different classes with a unified interface, right. So, that is one of the use cases, and decoupling logic. So, separating object creation logic from the main application logic. And the third point is dynamic object selection, right. So, when you are instantiating classes based on the runtime conditions, alright. So, whenever I mean I am talking about the dynamic, so you have that star, right. So, you have a class and then star object, right. So, when we use the factory pattern, so this is instantiating classes based on the runtime conditions. Next use cases is encapsulation, right, hiding complex instantiation processes, right. So, what are all the coupling we can have? So, the database connectors, MySQL, PostgreSQL, SQL, right, etc. we can do that, and user interface components for different platforms like Windows, Mac, etc. you have the factory pattern. So, these are all the use cases for factory pattern. So, how do I relate with the real world analogy? Alright. So, real world analogy, suppose you are going for a coffee shop and you want to have a coffee, alright. So, what you do, you order a coffee, so and then barista decides what did you order, whether you order a coffee or a tea. Assume that you ordered a coffee, and then you are expecting the output, right, result, right. You have to have a very good coffee, but you are not bothering about what exactly the content, right? Content in the sense how they mixed, all right? So, what is the percentage? I do not worry about all this, right? So, exactly the factory pattern is working like that, all right? So, in fact, this analogy we call it as abstraction, right? So, the factory pattern works in the same way, right? So, the factory encapsulates the creation logic, right? So, encapsulation means inside. So, how many percentage of coffee powder has been mixed, how many percentage of milk has been added, all right, how many percentage of sugar was put it in the cup. So, we do not know, right. So, only I want to have the final output, right, the final result. I want to have a very good coffee, right. So, in the same analogy, the factory pattern works, right. So, you are encapsulating the creation logic, and then the client simply requires an object from the factory, right. So, we can take the example with the same, the coffee factory, right. I named it as a coffee factory in C++, right. So, let us have include IOStream and include string. So, class coffee, all right. So, you have a pure virtual function called prepare, all right. So, that is equal to 0. So, we had seen this pure virtual function, and that is called as abstract, right, the abstract product. And here I have class espresso, right. So, class espresso publicly inheriting coffee, the class coffee. Now, I have void prepare member function, right. So, already it is there. I define as abstract class, right. When I put equal to 0, it is abstract class. So, this will be obviously overridden, and then I am printing preparing espresso, right, preparing espresso. And the next class, so this is a one class. So, espresso class is publicly inheriting coffee, the abstract class, and then I have one more class cappuccino, right. So, cappuccino publicly inheriting coffee again. Again you have the function prepare, right, you have the function prepare. So, which will override when you are calling this, when you are having the constructor, etc. We had seen many examples. So, C out preparing cappuccino, right. So, C out preparing cappuccino. So, now I have a class, right, the class coffee factory, right. I have the class coffee factory. So, here you go, I have an object create coffee, right, it is a pointer object under coffee, under the class coffee, right. So, here you have coffee by pausing the type, right. So, this is a reference type under string, right, the reference type under string. So, if type is espresso, return new, that means it is calling this espresso function, right. So, in fact, the espresso constructor, right. Otherwise, if it is cappuccino, return calling this constructor cappuccino, right. If both are not there, it is returning null pointer, all right. So, otherwise it will return null pointer. So, if the type is, let us say, espresso, it will return this one, all right, calling this constructor, return new this constructor, or if it is cappuccino, return new cappuccino. If both are not there, it will return null pointer, right. So, this is what exactly happening in this member function, which you call it as create coffee, right. It is a pointer object under coffee, all right. So, now the class is over here and you are having the main program. So, in this main program, you have object coffee, all right, in fact, the pointer object, right. So, the pointer object under the class coffee, all right. So, the right hand side, it is invoking create coffee, all right, it is invoking create coffee. So, this is the one, right, by passing espresso, you are passing espresso. So, if type is espresso, it will call this espresso constructor, correct. So, here you go. So, that means automatically here it will override, all right. So, it will go, in fact, assume that this object is calling prepare, right. So, now the object that you are creating, right, under coffee, right, since you are passing this and it is calling the espresso constructor. So, the meaning is, suppose the object is invoking, let us say, prepare, automatically this will be, right, overridden and this will be called, right. So, that is what you are saying, override, right, and then here you are passing espresso and then here it is returning new espresso. So, we know that now what will happen, right. So, when, right, if coffee, so coffee is not pointing to the null pointer because it is returning new espresso, right. So, it is not null, coffee is not equal to null pointer. So, therefore, it is invoking the object coffee, the pointer object coffee is invoking prepare using the arrow operator, correct. So, here you go. So, when it is invoking, so this particular function will be called, right, the member function prepare will be called, because the abstract class coffee you have prepare, but it is a abstract class, right, it is a virtual function. So, therefore, preparing espresso will be printed, right. So, when I run the code, I have to get the output preparing espresso, right, and then I am deallocating the memory for the object coffee. So, the delete coffee is indicating that I am deallocating the memory. So, then you are having return 0, right. So, that means I will get the output preparing espresso, right. So, I hope it is clear for everyone. So, coffee factory example itself we had seen, and this example, right, useful for learning factory pattern, right. So, you have learned factory pattern. So, in the previous example, right, client code, what do you mean by client code? So, the main function, the client is nothing but a main function, simply requires a coffee type from the factory, correct. So, that is what exactly the main function is doing. Here you go, the main function, it is simply requesting the coffee, all right. So, you have coffee, that is a pointer object under coffee, and you are ordering create coffee espresso, that is it, exactly the same analogy, right. So, you are creating espresso. So, once you are doing this, what is going on inside, right. So, you are passing espresso. So, if type is equal to espresso, the new espresso will be called, right, the constructor will be called. So, when you are overriding, correct, when you are creating an object like this, yes, I am creating an object by calling create coffee, all right. The object is a pointer object in line number 31 under coffee class, correct. So, when in line number 32, if coffee, right, so coffee is not equal to null pointer, right, because it is returning espresso, new espresso, line number 24, right. So, when it is invoking, so we know that espresso, it is calling that particular constructor, and line number 13 prepare, because coffee is invoking that, preparing espresso will be printed, right. So, this is what exactly called as the client code. So, the main function is simply requesting a coffee type from the factory. So, then you have encapsulated all the logic in the factory class. So, that is called the factory class. So, if you look at right over here, yes, coffee factory, right, in the factory class. So, you have encapsulated everything, correct. So, line number 21 is a factory class, up to line number 28 you are encapsulating the complete logic, all right. So, this is what exactly we have done, and the concrete products are espresso and cappuccino, right. So, which implements the coffee interface, right. So, here you have the interface, correct, the class coffee which is abstract, correct. So, here espresso and cappuccino, if you look, so they are inheriting from the coffee, correct. So, this is what I am talking in the theory, right. Espresso and cappuccino implement the coffee interface or from the abstract class, right. So, what are all the benefits? So, simplifies the client code, right, the main function. So, in the main function you are just ordering, all right. So, this is what exactly you are doing, all right, create coffee, you are asking make a coffee espresso, all right. So, that is what simplifies the client code, and it is easy to extend, all right. So, we are having initially we have a coffee class, and then we are extending the new type, right, cappuccino and espresso, right. So, we have added a new coffee types by creating a new class, and we have also updated the class factory, right. So, I hope it is clear for everyone, all right. So, now, so let us consider one more program for the factory pattern, all right. So, in factory pattern, so here we have the class shape, all right. So, here we have class shape. So, here the pure virtual function draw, all right. So, that means I have to inherit this in the subclass. So, here you have the class circle. So, publicly inheriting shape, all right. So, the draw will be overridden and see out drawing circle, all right. And I have another shape called square. So, publicly inheriting shape, all right. So, here you have void draw, so which will also be overridden and then here you have a print drawing square, right. The class is over here for square, the class is over here for circle, and the class is over here for shape, the abstract class, right. So, now shape factory, all right. So, I create the shape pointer object under shape, right, by passing certain type, right. The type is nothing but the reference type, which is a string, right. So, if type is equal to circle, exactly like a previous program, type is equal to circle, return new circle, that means it is calling this constructor, right. So, circle is the class here, right. If you are passing square, return new square, otherwise it will return null pointer, all right. So, your factory class is over here, line number 28, shape factory. So, now int main, I have a pointer object shape, right, I have a pointer object shape. So, under, in fact, this is a pointer object under shape, right. So, right hand side create shape will be invoked by passing circle. Now, you are passing circle, right. So, when I am passing circle, this particular function will be invoked, and you are passing circle, therefore, the type will be circle. So, if type is circle, return new circle, right. So, that means this particular constructor will be called, that means it will be in the class circle. So, now when you are creating an object, yes, I have created an object shape, that is a pointer object, right, and if it is invoking, obviously if shape, so shape is not equal to null pointer because it is returning the new circle, line number 24. So, now when it is invoking, the shape is invoking draw. So, as I said, this will be going to this particular, in fact, this draw will be overridden and it will go over here, and the drawing circle will be printed, right. So, when I run the code, I have to get the output drawing circle, right. So, now you delete shape, right, that means deallocating the memory for the object shape, return 0. So, when I run the code, I will get the output drawing circle. So, this is another example of a factory pattern, right. So, in the next lecture, what we can do? So, we will talk about the same factory pattern program with the help of Java. Okay. So, we had seen in the case of C++. So, we will see in the case of Java. So, factory pattern, if you look, we have seen two different examples, right. One is the same coffee factory example itself, right. Another one, mathematically, if you take some shape, right. So, let us say circle or square. So, now you can understand how this factory pattern in C++ is working. So, we have done two different implementations. So, with this, I will conclude this lecture, and we will see the same factory pattern example in Java in the next lecture. Thank you very much.